Thank you for joining Gwinnett County Public Library for the Climate Intervention Workshop. My name is Amy Perry, and I'm an Adult Services Specialist here at the library. Today's workshop is in partnership with Citizens Climate Lobby, Gwinnett and Forysth chapters, and the Sierra Club, Georgia's chapter, Greater Gwinnett Group. The presenters this evening are Kathy Gowland, an En-ROADS Climate Ambassador and Citizens Climate Lobby co-leader, Bob O'Brien, an En-ROADS Climate Ambassador and Citizens Climate Lobby member, and Ken Kirby, who is a Citizens Climate Lobby co-leader. Please welcome Kathy, Bob, and Ken.
This presentation will be a brief introduction and overview of this awesome and fun tool, and it has a very important message also. There are many resources for people who want to dig in further at climateinteractive.org. Also, we're always happy to talk with anyone about En-ROADS and most things climate related. Our agenda tonight, we are going to do a quick background on greenhouse gases, and then talk about some of the impacts we're already seeing with climate change. And then we'll model the Earth getting cooler, or at least a little less hot. And then we're going to take time for reflections and takeaways. And as Amy said, we'll have question and answer time, and then talk a little bit about resources that you can look forward to. We'd like to start tonight with a little poll about how are you feeling about climate change? We're going to launch that poll in just a second. And while you're answering that question, I wanted to tell you that these images you see here are warming stripes. And that's another useful visual tool for understanding climate change. You see the global on the left and the Georgia ones on the right. This was a tool that was created by Professor Ed Hawkins at the University of Reading in Berkshire, England. And you can Google this or look for it on the internet by show your stripes or just warming stripes and find that. Okay, it looks like we are preaching to the choir here tonight. All of us are a little alarmed or concerned. So thank you very much for that. And you can see in the background on this slide that according to the Yale program 6 Americas survey, the number of people who are alarmed or concerned about climate change is over half of our population, and these numbers keep rising, so you're not alone. Climate scientists and activists have also been talking about dreaded climate tipping points. Severe weather and the steady drumbeat of climate-related disasters that we're experiencing have created a social tipping point that even politicians have started to recognize. Finally, it seems like we're really on the verge of hopeful possibilities in the future. Recent news articles have even pointed out that your neighbors and friends might be more concerned about climate than you might think. So it's helpful to talk to others about climate change. And that can be helpful to bring that tipping point about. And it's also very good news for the climate. So Bob is going to give you some background information on greenhouse gas emissions that are causing our climate emergency.
Hi, it's Bob O'Brien. So the greenhouse effect, I'm sure you've all heard about it there, but there's actually a natural greenhouse effect that we have. The Earth would be a ice ball if we didn't have this greenhouse gases that re-radiated heat that comes in from the sun. In fact, Mars has a greenhouse effect as well. But what's been happening since the beginning of the Industrial Revolution is we've been adding a lot more greenhouse gases, and this is heating up the atmosphere and heating up the Earth. There's a lot of talk about, it being a greenhouse, but I think the analogy I think of more is that you're in a car and you have that nice, comfortable. You got the windows partway down and you're sitting there. But these windows are going up, and as you raise your window, it starts getting hotter and hotter, and that's what we're doing to ourselves and to our children. And so part of this is to slow down the amount of gases that we're doing, and to get to zero. A longer term goal is to get the windows back down, and that's a huge challenge for us. So back in the late 60s, we started making direct measurements of CO2 in the atmosphere, and this is from Mauna Leo in Hawaii. And you see the sawtooth pattern that goes on. And what you'd normally expect, you would expect the sawtooth pattern because the peak of there is that you pick out here, just pick one here, is that's like typically the beginning in April. And as things bloom, particularly across North America, all the forests and grasses, the plants, they suck in the CO2 and put out oxygen. But then when they come to the fall seasons and the leaves drop and they go into remission, the CO2 comes back out. What you would expect is this to be kind of going along at a natural rate. But you see what we have is the sawtooth pattern, but going ever upward. And we really haven't had this level of CO2 in the atmosphere for the last 800,000 years or more.
So as we've seen, Earth is getting warmer, and it isn't just the temperature increase that's the problem. It's rather what this increase is causing. As when humans have a temperature, Earth's relatively rapid and continued warming indicates that our planetary systems are stressed and out of balance. So let's look at a few examples of this.
So, what's the big deal about a few degrees? The temperature's changing all the time. Well, it's not just that the average is changing. I mean, an average is actually pretty significant, but and when we see this, this summer and right now around the world, we get more extreme hot weather. So, and then those extremes, have greater impact. But also is we get less extreme cold weather. It doesn't get quite as cold. And, normally you think, well, that's in general, that's good. But if you're a farmer, it's particularly fruit trees, you need a certain number of days that are below 40 degrees or 45, whatever it is. And or your crops, you're going to get a much lower yield on crops. And that's actually a big deal to Georgia. They just from blueberries, for example, we're the leading state for blueberries. So it has a lot of implications beyond just, oh, it's going to be a little bit warmer and my air conditioning bill is going to be a little bit higher.
And here you see two graphs from the En-ROADS model. The left graph shows global sources of primary energy, and below that you see the colored key. This represents our baseline or reference scenario, or our starting point for studying this future. If we don't take any actions, we're on a trajectory to need a big increase in energy from these sources, or about double what we're currently using in 2022. And we'll need that by the end of this century. You can see that the graphs both go out to 2100. If we use this much energy from this mix of sources, we'll also see a big increase in particulate matter in the polluted air resulting primarily from burning coal, which is shown in the big brownish purple mass at the bottom of the right graph. And this is the stuff that irritates lungs and exacerbates respiratory illnesses. It creates heart disease and can cause cancer. This is especially a problem for those already living in frontline or otherwise marginalized communities. So what this scenario is telling us is that if we don't change anything, we're likely to see these kinds of impacts by 2100 and continuing beyond that. So let's see what we can do to make a big difference in this trajectory. And we're going to use the En-ROADS model to do it.
So one last slide before we get to the En-ROADS model. En-ROADS says Energy Rapid Overview and Decision Support. It's a global model. So it assumes in order to make it useful here and something we can do in real time, it just assumes kind of things that are changed happen globally. But the best way we're going to be able to do this is by having interactive, is because research shows that showing people research doesn't work. So, we want you to kind of get involved and make suggestions on this. So away we go here. And this is the model, as you can see, and it looks very similar to what Kathy was showing. And we have primary sources of energy and then greenhouse gases, net emissions, And then we start off at kind of the path we are on is that to heat up by 6.5 degrees Fahrenheit or 3.6 degrees C. So the challenge for us is to get down to 1.5 degrees C, or which would be about 2.7 or something like that, or 2 degrees C, which is 3.6 degrees Fahrenheit. And the way you use the model is that, and this is a model that you can, after this, you can go and type in En-ROADS Climate Interactive and play with it yourself. But what you do is you move some of these sliders and you see what the effect is. It's really got a very nice interface into it. It's very layered in terms of you can do it very simply, and then you can dive, and there are a lot of details that are behind it. So if you want to learn more, you can. So I'm going to start off this by changing the scenario. It was, making cars and buses electric is obviously a big thing that's in the news all the time. And what I'd like you to do is, and if you can put in the chat, is what do you think the impact of that's going to be? How much are we going to be able to lower the temperature that we would see by 2100? More. I'm going to go ahead and give my example. So electrification really didn't make a big difference here. It just knocked it down by 0.2 degrees Fahrenheit, which is, I don't know, the first time I thought that was kind of surprising. What's maybe not as obvious here, and this is a nice little feature, can replace this 3 times. Yeah, you see, less oil gets used because this is coal, oil, gas, etc. And so we get less oil, but if you look here, we actually get more. We're using more coal. And when you start to think, well, why would that be? Well, if you electrify everything and you don't change anything, you're going to use the cheapest energy source to generate electricity, and that's coal. And as I was mentioning, there's just a ton of things in here that you can go take a look at. Each one of these little triangles has 10 or so on there, different subgraphs you can go to, and you can see what happens. Oh, well, when we do that, just electrify, we get more coal. So, okay, and then we go back to the default graphs. So we've electrified, but now, could give somebody an idea of something else we might try. And then what we have is, you can change things in the energy supply. It can be coal, or less coal, more renewables. You have efficiency on transport or buildings, or kind of growth we have, and then what kind of emissions we'd have, and then we have some things around carbon removal. So, any suggestions for what we might try next?
Karen Harris says, can we bring things down to 3.5 somehow? But
Sure.
someone else is asking, will lowering nuclear or oil make a big difference?
All right, so we can lower the oil, and do they want to lower nuclear or increase nuclear? We can, well, just for giggles, we'll just make more nuclear. And so that brought it down to like 6.1 degrees or 3.4. So moving in the right direction. And you can see here, actually, I got to take this. Let me do this one at a time. If we highly tax oil, we see it goes down, and what you see is there's a little bit of increase in renewables, an increase in natural gas here. If we put more nuclear in, that will should wind up impacting coal a little bit. You see this coal go down because we've got this other source for generating electricity. So we're moving in the right direction, but it's not a big impact. So What?
Karen Harris is saying coal needs to go way down.
Okay. So we'll go really high in coal. And then you can see that that's a big drop on the amount of, now we're down to 5.5 there. So we're getting there. And
Can you
one of
replay
the things,
that, everybody?
oh
Replay.
yeah, sure.
Yeah.
So you see, and then, Kathy showed this graph before we started this, is what was some of the impact on air pollution. And what you see here is that by impacting coal, we really reduce the amount of particulate matter, which is one of the big health concerns there, which is, it impacts people today, will be more in the future. But you notice one thing is that the model just doesn't assume things always get better, because as you have more people, more income, there's a greater demand for electricity, and again, some of these things come back. So it's not just purely driving out coal. The coal is much lower here than before. You can see renewables went up quite a. All right, so we're at 5.5 now. When I first thought of this, I kind of imagined it would be a pretty big, maybe not as big on deforestation as afforestation. So deforestation, it's just taking it down like another 1/10 of a degree. But let's go ahead and just look at what afforestation does, because there's a lot of talk about trees on this, and we're going to just put in as many trees as we can. And wow, that only has, oops, here, really another like 1/10 of a degree, which is, oh yeah, Kirsten, that's what I would have thought too. And so what's really nice about this, and it kind of allows you to kind of probe and think about things, as you look at, you can click on these little dots here, and you can see what's the impact here, and you can go and you can change some parameters if you want, like common planning time. But just to pick on afforestation, you don't see, it doesn't get high until really out to 2080, and that's because you can't plant all the trees at once, and it takes a while for them to grow, and they got to get big before they're bringing in a lot of sucking in a lot of CO2 out of the air. So that's one of the things that's in here, is that they're assuming it takes you 10 years to get the land. If it was 5 years, well, then would change things, maybe not real significantly, but so that's things you can look at and see on this. And the other thing is, just when we're second on this, is there's a lot more information on it, and you can talk about what are some of the examples, whether dynamic, so you're just interested in it, you can go see what are a lot of things. And it also has equity considerations, what the slider settings mean. So as I said, a lot of layers to this for you to explore. Okay, so we're down to 5.3.
Bob, can I say another thing about this afforestation? Because
Sure.
it's hard for people to write in the chat, but one of the big equity considerations for this is that afforestation doesn't mean just planting a few trees in downtown Atlanta or something like that. It really means a huge amount of land. And we have to consider, when we're talking about this, where that land is going to come from, how much land are we going to need, and who has it now, what are they using it for now. So that's a big equity consideration. Studies have shown that it would take about the land mass of India to make any kind of afforestation helpful to our climate.
Yeah, I think I pulled up the wrong, just the amount of land use. Here we go. Yeah, so this dotted line is the land area of India. And so, yeah, and that just besides being a huge amount, that you've got to also consider, you know, you have land use that's just for growing agriculture for the food we consume. So, so one other thing is to kind of, maybe this helps or not with people, is these kind of, what's a high level view of what's going on with the model. These are called Kaya graphs. So what the model does at a high level, it takes what's the global population, what's the GDP per capita, what's the energy intensity of the, and so this gives you what the GDP is. This is the energy intensity of the GDP. And then is the carbon intensity, the final energy, and that gets you to the CO2 emissions from energy. So, you know, even here you can see the energy intensity of the GDP. I mean, really, even the baseline is going down pretty far, and the carbon intensity is going down far, but we've still got pretty high temperature that we'd reach by the end of the century. So we need to figure out what more to do on this. So to go back to the default graphs. Oh, change in population, good thing. And we got, and Bill, I'll come back to methane after population. So, oh, you want to see both? Okay, all right. So it would just decrease it by 0.2. And so what you see in this case is the overall amount of energy being used is reduced. So if we go and, you know, and it goes, you know, 0.2 was it. If we go and increase the population growth, you can see what's happening is the overall energy is use is being increased. And there's kind of a actually it looks like renewables go up the most, but kind of they all kind of move up a little bit. So we'll go back to lowering the population. And a lot of that, if you go and look at the population, is you know, lower growth. You can find out that assumption about demographics and fertility rates, and usually empowerment and education of women reduces the fertility rates. All right, we're down to 5.1. What's next? Bill had tried reducing methane, and so Bill, what do you think? So 1 degree. Okay, so we're gonna really reduce methane here, and it almost is counts. So what you see here is methane is itself reducing, and methane is a greenhouse gas. And also, if we were to reduce natural gas here by quite a bit, we would get down to 4.1. So we're getting close to that. And if we replay that one, there you're seeing the natural gas go down.
Nobody else has a suggestion. I'd like to see what energy efficiency in transportation and buildings would do.
All right. Okay. Yep.
Heard a lot about it, so I think it might make maybe 2/10 difference, or maybe 3/10.
Yeah. So the energy efficiency and the electrification, actually, the transport didn't do a lot, and maybe that's because we took a lot of the coal and oil and natural gas out of there.
Right.
Yeah. So just let me do this for a second here, and I'll put these all back. But if you went and you did energy efficiency and it was 4.9, and then you did it, it's still not a huge impact. Okay. All right. I thought it might be bigger, but let's see about buildings, what that would do. So that does have actually a pretty big, and that, again, this is one of those ones where you can see where it's lowering the total amount of energy we're using. So we're actually lower out in 2100 than we were in 2020 if we could do that. And maybe let's electrify the buildings and
Yes.
as well. Yeah, that's not having a big impact either, though. But we're getting close.
Well, and I think again, that's partly because we still have our energy supply has already restricted fossil fuels a good bit.
So we got a suggestion here for about economic growth. So let's get back. That certainly does have an impact. If we had a lot less, we would get down to 2 degrees C. That's generally not popular. But less economic growth. And this is gross world and you see the difference of trillions per year. If we were to go down to long term of 0.5% of growth, so it's not a negative, but there's a, as compounding goes, makes a huge difference in the amount of trillions of dollars in the global economy, going from something that's by 2040, when it really kind of breaks out here, with 300 versus 700. So, but yeah, we'll leave that in there. And then again, you can read more about it and dig more into it if you're interested. Okay, how about renewables? I'm going to say, and that's part of the Inflation Reduction Act had on renewables. So let's crank that up real high. And that just did 1/10 of a degree. So again, it's
Can you replay that, Bob?
Yeah.
Look at the left graph. Why do you think it didn't make that much difference at that point?
I think because we've gotten rid of coal.
Mm-hmm.
I mean, I think it's a little bit harder because we also, yeah, you can see some of it.
Yeah.
I think actually, if you put population and growth back and then did this, you would see you can see a bigger impact. Yeah. But we're going to go back to what we had here. Oh, I think it was probably up.
Right. What if we wanted to try a carbon tax?
Okay. All right. So we'll say a big carbon tax, and that does make a pretty big difference on it. And so now you can see that really kind of your coal, oil, and natural gas are really almost phased out, except for a little bit, and it's mostly renewables, nuclear, a little bit of bioenergy.
Yeah, so we have
so
getting below
Missy, yeah, so Missy, to answer your question, this is a global model, so yeah, so it's artificial, so in terms of the model would say that you have to do, the US represents about 14%, 15% of the emission greenhouse gas emissions globally. So things we do have an impact, and also, which we may get into a little bit later, things that we can do in terms of trading, or be done to us, but in terms of trading can force other countries, if they want to trade with us or we want to trade with them, to in order to they may have to take actions to reduce their greenhouse gases, either through trading carbon credits or having a price on carbon.
The one thing that we haven't tried so far, well, two actually, is technological solutions, and then for carbon removal, and then bioenergy. So, and
yeah, and new carbon,
right.
New zero carbon. So which one should we try first, Kathy?
I think I'd like to try the carbon removal. I hear a lot about that in the news, that people are talking about,
Right.
carbon storage and sequestration.
Right.
So what kind of difference do you think it would make?
So that actually has a relatively big difference. So we're now down to 2.7 or gotten down to 1.5. So, and the thing about this is, you know, when I talked about the analogy of having the car window, it's about trying to get the window to actually lower. This is showing that the amount of CO2 that's being emitted in the year. And you can see if you have this carbon renewal, you can actually start getting lower the amount of carbon in the atmosphere. The challenge with this is that much of that requires that and you can see there's afforestation, all these different contributors, but some of these like direct air capture, mineralization, bioenergy, carbon capture, some of these require technological improvements or have to get to a price point where it's, you know, it's viable. So that's one of the challenges. And again, you get all these different, you know, like, well, what's this BECCS? Well, it's bioenergy with carbon capture. So again, you get a lot more information there.
And sometimes you
Yeah.
can see what is going on better in some of them. So like Bob was talking about with the net greenhouse gas emissions by gas, it's showing you that we're actually drawing down because of all the solutions. The amount below that horizontal line that's where we start to actually draw down with both the forestry and afforestation and the other technological solutions. So.
Right. And then I'm still gonna one impacts. So additional deaths due from extreme heat, kind of the baseline model is you would, you know, for Southeast Asia, you'd cut it probably in a fourth of additional deaths. East Asia, maybe a third. North America, you know, wouldn't have as big of an impact, but still kind of reducing the impact there. And then the other one is lost species. And you see that what kind of huge impact as you make these. And these, you know, these kind of projections, they have background for how they're projecting for this. And there's more that you can investigate or read about on this.
Okay, let's celebrate that we did succeed in our success scenario building. We got down to the original Paris target of 1.5 degrees Celsius or 2.7 Fahrenheit, and that's great. We are excited about that. And what you probably noticed is that it took a lot of actions in many sectors to reach that success scenario. And the thing with this is that timing is urgent. The longer we delay, the more aggressive action we need to get to those targets. And every 1/10 of a degree matters. We've said that before, but we'll keep saying it because it's so important. It matters now as well as in the future. And so there will never be a time when we don't need to be working on this. There's just no room for hopelessness. We are hopeful. Think about how you're feeling now after what we've just talked about. The information and the topic that we've talked about can be overwhelming. So it's important to sit with it, sit with your feelings and see just what comes up for you. Or you can just sit quietly and imagine what you would love about being alive in a world like the one we've just created together with the simulator. Imagine how this success scenario would lead to a much more livable world as compared to the baseline scenario that we started with. So we're going to take a minute just to think and feel. And it sometimes feels like we're climbing up a mountain to do this work, but it is so important. And as they like to say, it's not going to be easy, but it is going to be worth it when we get to this point. This is a slide created by a friend of ours, and it's in rows with a Georgia flair. So you can see that Georgia has some good things already going on. from the standpoint of solar panels and nuclear with Plant Vogtle almost online, hopefully, and with with the electric school buses, the Bluebird plant and headquarters that are in Georgia. And then we also have a very active Georgia Forestry Commission with a carbon registration that's going to help a lot of people out, both in terms of earning some money from that, but also from being able to, offset the emissions that they're using. So a lot of good things going on in Georgia already. Well, and this is another example. These are using slides from the active simulators. So you can see here in the left-hand corner that these sources of energy have been, fossil fuels have been put very highly taxed. So they're almost disappearing, and nuclear has been encouraged. And with that, if you remember, we started with 6.5 degrees F, and now we're down to 5.4. So that has already made over a 1 degree difference. You can see that those differences are still there, but we've added 5, 6, 7, and 8, which is energy efficiency and electrification of transport, and then energy efficiency and electrification of buildings and industry. And now we're down even to 4.3, which is a good bit more. And the thing about this is it's really easy to move these sliders and inroads, but each one of those would probably require a separate legislative or regulatory policy to enact. So is there a single policy that achieves similar results? That's what we're looking for. Yes, there happens to be. And that's why CCL has always been a big proponent of a carbon price. And even now that the Inflation Reduction Act has been passed, which is excellent news, we feel like this would be an excellent complement to that law, because you can see from the 3 dots here that we've got some things going on in the background. So if we start with a low and rising carbon price, that would give our economy time and the market certainty that it needs to continue to innovate. It's also a powerful effect on which sources of energy we're going to be using. If you look at the left graph, you can see in the future, it's almost all renewables, and how much greenhouse gas net emissions are improved or lowered in the right graph. If this policy also happens to include dividends to return to households for their energy use, even though they might be taxed more highly at the beginning of the use of these fuels, they will get money back, and that will keep this policy being a win-win for environment and for consumers.
So a little bit about the Inflation Reduction Act. It's mostly carrots, incentives, and tax credits. So, clean electricity credits, wind and solar, individual green energy taxes, clean manufacturing, more nuclear, rural development, agricultural conservation. You can electrical car credits, working on clean hydrogen. There is a fee on methane, and so there's the stick in there, and that was actually kind of surprising, because we thought that it would just be all kind of on a carrot side, and it's there's been some credible initial analysis, and it really looks like we can reduce CO2 emissions reductions by 40% by 2030. So that's a great step for us. We need to do more, but it's certainly a bigger step than we thought was going to happen 2 months ago. So just a little bit more on the Energy Innovation and Carbon Dividend Act. That was something that Citizens Climate Lobby has been pushing to both Democrats and Republicans, and it's effective. It's good for people. It's good for the economy. It's bipartisan. It's something that really affects and helps the overall economy there. One thing that it wasn't kind of maybe as obvious in when we talked about a carbon tax or carbon fee, however you want to put it, is that it makes a difference right away. Many of these things, it takes a while to get started if you're going to plant trees or whatever, but as we know, people respond to prices, and that really makes an impact right away. So that's the other part about what the advantage of carbon fee. And if you talk, the economists, by overwhelming majority, believe that the most effective thing could be to do is a carbon fee or carbon tax.
There is really no silver bullet, but there are what the people that developed this and other people have called silver buckshot. So a lot of different actions are required. So everybody has something to do. But the highest leverage is always keep fossil fuels in the ground, and that's important. This is an urgent situation, even with the passage of the IRA. We still have a lot left to do to get to net zero by 2050. But avoiding the worst case is still possible, and every 1/10 of a degree matters. So there are abundant near-term co-benefits from doing these actions as well. So it really helps with environmental justice. It really helps with our economy, because so many of these climate disasters take human tolls, but also very much monetary tolls. If you think about all of the heat domes and droughts and floods that are going on, not only in America, but all over the world, this model will really reflect that. And hopefully these co-benefits will win out in the long run.
So, solutions are going to take all of us. And it's what, it's part of what you can do. I mean, obviously it's how we live our lives, how, people that get elected, what priorities we take. And, kind of everybody here who took the initial poll were alarmed or concerned. And a recent survey was done that kind of isolated out that your neighbors are more concerned about climate than you might think. And that it's one of the things that kind of, and I've certainly like this, you don't want to be bring up stuff that caught people uneasy, but if you kind of ease into it, it's worth talking about, because it's something you can't run away from. It's putting CO2 in the atmosphere, it affects everybody, and it'll affect today, it'll affect them more tomorrow. What we can do to reduce it will make our lives better.
This is Marshall Saunders, who is the founder of CCL. And I love his quote. I used to think that the important people were taking care of the important problems. I so relate to that. But he doesn't think that anymore, and neither do I. Preserving a livable world is up to us little people. What you and I do and do not do has a profound effect upon the world. What we do and do not do really counts. So remember, politicians don't create political will, they respond to it. Even if we level off emissions, concentrations are already so high that we've got a lot in the bathtub. And it takes a long time, as we've talked about, for CO2 to dissipate from the atmosphere on its own and to be drawn down is not happening fast enough. So the net removals are much smaller than the emissions. And because of that, you can see on the CO2 concentration graph that continues to go up until we actually bring the emissions down below where the removals are. So on the left graph, if we could actually move that red line down below the blue line, that's what we call drawdown. And that's going to be important for us to achieve to get the temperature to come back down. I think the main thing, as Catherine Hayhoe, who's a great climate scientist and communicator, says, is talk to other people, join with other groups. We do have a list of resources here. And as I've mentioned, CCL is doing a lot of things nationally, and Sierra Club is doing a lot of things locally. Plug in with one of these groups, get yourself educated and talk to people. That's, to me, some of the best things that you can do.
The other thing is to vote for people who, that's probably the main, and people who are concerned about the environment actually tend to vote less.
The list of organizations that we know something about, there are tons of them out there in the universe, but these are ones we're actually involved with. And CCL has done a joint project with Environmental Voter Project. So that is exactly what Bob was just mentioning. That's the impetus for getting people out to vote, is calling people that we know are pro-environment, so that we're trying to get them to definitely go out and vote.
And we just ask them to vote. We don't ask them to support a
Right.
candidate. We just ask them to vote. That's all.
Another thing that I just want to point out on this page is Project Drawdown, which was created several years ago by Paul Hawken, is a great website, but we also have a version of that in Georgia that is very active and very helpful. And that's Drawdown Georgia, which is a collaborative between several of the major research universities. And they are doing some great things with business collaborations, et cetera. So they're always looking for volunteers as well. We hope that you will use this tool and learn more, and then join up with us and call us on us anytime. Thank you.
Yeah, reach out to us if you have any questions.
The Gwinnett Public Libraries and to Climate Interactive and the Multi-Solving Institute, and especially I should single out Amy because she's been awesome to work with. And additionally, thank you to all of our fellow volunteers in CCL and Sierra Club, and especially to Dr. Terry Walsher and Laura Iyer for use of some of their slides. And thank you all for attending.